Welcome to Coach Taylor's Geometry videos, and this is Unit 1, Lesson 1. So today we're going to talk about the different types of reasoning or thinking that we use in mathematics, especially geometry, and how these things relate and how we're going to use them moving forward. So the first thing we're going to talk about is we're going to talk about this concept of inductive reasoning. So inductive reasoning is making a conclusion based on patterns, observations, past experiences, and events. So inductive reason is basically, it's once you've seen something, you're trying to figure out how it happens, and so you kind of make a hypothesis. So we call that hypothesis, or that conclusion that you draw, a conjecture. So conjecture is a conclusion based on inductive reasoning. It is often unproven. So we're going to look at some examples here where we would use inductive reasoning and how they can help us in math. So we're given a pattern of numbers in this first example. So we go from 38 to 31. And so what I notice is we go down by 7. 31 to 24, we still go down by 7. 24 to 17, we still go down by 7. So the conjecture that I'm going to make is that each term is subtracted by 7. And so if I were to fill out the rest of the term, we should get 10, 3, negative 4, negative 11, and then finally negative 18. So this is what I think based on the pattern. Could there be another pattern? Maybe, but based on my observations and what I can tell, that is what is happening. So now let's look at this next one. So the difference between 2 and 5, they added 3. The difference between 5 and 11 is plus 6. Difference between 11 and 23 is plus 12. So what I notice is that each number that we're adding is being doubled. But if I look at the same time, if I look at these numbers here, I just added 1 to the number itself. So if I were to develop a pattern or develop a way mathematically to think about this, 2 times 2 plus 1 gets me 5. 5 times 2 plus 1 gets me 11. 11 times 2 plus 1 gets me 23. So my pattern is going to be to multiply each term by 2 and add 1. And the way that we can write this as 2x plus 1 is my pattern. So 23 times 2 would be 46, plus 1 would be 47. 47 times 2 plus 1 would be 95. 95 times 2 plus 1 would become 191. 191 times 2 plus 1 would be 384. And then 384 would be so on and so forth. 7, let's see. It should be 767. So again, using the information we have, we've got to find and develop a pattern. On our next pattern, I noticed that it's written as time, and this is going to be dealing with time. And so 30 to 55 is 30 to 55 is 25 minutes. 55 to 20 is also plus 25 minutes. So my conjecture is that we're going to add 25 minutes to each time. So we're going to end up with 8:45 We're going to end up with 9:10, 9:35, 10 o'clock, and then finally 10:25. So when we have conjectures, we try to look for what we know as counterexamples. So a counterexample is an example that proves a conjecture false. So again, a lot of the times our conjectures, sometimes they end up being wrong. And the way that we try to figure out if they're wrong or not is to look for that counterexample. And if we cannot find a counterexample, then we know it's true. But if we are able to find a counterexample, then we know that our conjecture is false. So this first one is we're looking for the sum of any two consecutive integers. So these are numbers in a row is always odd. So let's look at some examples and see if this is true. 1 plus 2, because 1 and 2 are consecutive numbers, equals 3. 2 plus 3 equals 5. 3 plus 4 equals 7. And now let's try some different numbers. Let's try negative 2 plus negative 1, which is going to become negative 3. Let's go negative 20 plus negative 21, which equals negative 41. So I've come up with 5 different examples. I can't think of another one, and it seems like they're always going to be odd. So this conjecture is true. All right, so let's look at another conjecture. Squaring a number and adding 1 will always result in an even number. So I need to square a number and add 1. So 1 squared plus 1 is going to equal 2. 2 squared plus 1 is going to equal 5. Well, so 5 is not an even number, so this proves that my conjecture is false, and 2 squared plus 1 equals 5 is my counterexample. All right, so now let's move on to our second type of reasoning, and this is the reasoning that we're going to use the most in geometry, and that is deductive reasoning. Deductive reasoning is making a conclusion based on facts, rules, and logical thinking. So our deductive reasoning is we are following rules. It's not just observations. It's not just what we see. It is concrete things that we know are true, and we use our logical brains to use those rules, use those facts, and then to make conclusions. So one way that we use deductive reasoning is by Sudoku puzzles. So in Sudoku puzzles, we have a few set rules. We know that each row must have 1 through 9. We know that each column must have 1 through 9, and we know that each box must have the number 1 through 9, and we cannot use a number twice. And so we have to use these rules and use our deductive reasoning to find the right answer or the right way to arrange the numbers in the Sudoku. So one way that we can think about this is by using our process of elimination. So I need to make sure that I have a 1 in every spot that I'm supposed to have it. So I cannot have a 1 in this row since a 1 is already there. I also cannot have a 1 in that row since a 1 is already there. Same for that one, same for that one, same for that one. Now we start looking by columns. So I cannot have a 1 there, it cannot go there, it cannot there, and there. And now I need to look at boxes. So 1's already there, there's already a 1 there, there, and there, and there. And so now I'm left with only a few spots where the number 1 can go. So in this row right here, there's only one empty row left, and that's where my 1 is going to go. If we look at this row right here, there's just one empty open spot, so that's where my 1 goes. Now that I've put my 1 there, that means it cannot go in this row either. And so if we look at the bottom row, I've got 1 available spot. Once I put that there, this spot here goes away, and I'm left with 1 last option. And so that is where my 1 goes. And so you do this so on and so forth until all of the spots are filled up and there are no empty boxes left. I'm going to do it for one real quick. We're going to do it for another number very, very quickly. But now I know that I have 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9 number ones, and none of them go in the same spot or in the same location. All right, so let's look at 2s now. So I've got a 2 there, there, and there. I've got a 2 here, here, which eliminates there, it eliminates there, and it eliminates those spots there. So now I'm looking for rows that don't have 2s and looking for where I put them. So I've got an empty spot here, and once I put that 2 there, this goes away, and this goes away. I'm left with a blank here where a 2 can go, and then that eliminates those options. And so I've got a 2 that can go there, which eliminates those options. So I'm left with here, which eliminates that, which then 2s can go there and there. And so that's how we work through Sudokus, and that's how we use our deductive reasonings and use the rules to find out where things go in a logical order.